Hello everyone, welcome back to the series where we are solving past 20 years of JEE Advanced question. This question was asked in 2018 and it was multiple correct type. So let's see what it says. So it is given that a particle of mass m is initially at rest at the origin. It is subjected to a force and starts moving along the x-axis. Its kinetic energy changes with time as dk by dt is gamma t, okay, where gamma is a positive constant of appropriate dimensions. Which of the following statements are true? So as usual, all of you guys can pause the video and try to solve it by your own as question is visible on the screen. If once your attempt will be done, you can resume it, okay. So the initial conditions are given that at t equals to 0, particle was at origin, so I can say x was 0 and u was 0, okay, it was at rest. So these are our initial conditions. And if I say what else is given, dk by dt is gamma t. What is k? K is kinetic energy, which is half mv square, okay. So I can say half mv square is equals to gamma t, differentiation of half mv square is gamma t. If we differentiate it, what we will get, mv dv by dt is equals to gamma t, right? Doing simple integration, okay, if we integrate it from 0 to v, from 0 to t, because at t equal to 0 velocity was 0, so I can write 0 here, it was given, right? At t equal to 0 particle was at rest. So on simple integration we can apply this, mv square is equals to gamma t square, right? So also we can write v square is equals to gamma by m t square. So velocity is nothing but plus minus root of gamma by m t, okay. Here plus minus just indicates, what does this indicates? It indicates the direction, right? Because magnitude is always increasing, so plus minus only indicates the direction. So we can assume the plus one and solve further. So velocity is root of gamma by mt. Again, if I write velocity as dx by dt, rate of change of position with respect to time, I can write it as gamma by mt, bringing t here, dx is equals to root gamma by m t dt, and again differentiating from 0 to x and 0 to t, we can say x is equals to gamma by m, root gamma by m t square by 2, okay. So our velocity and x is done, so I am just writing it here again for our conclusions for the options, gamma by m t square by 2, this is our position. Velocity is root gamma by mt. Acceleration is, again I am just differentiating, root gamma by m. Fine. The force applied on the particle is constant. Yes, because acceleration is constant, it means force was constant, because force is nothing but ma, mass is constant, so a is right. The speed of the particle is proportional to time. Speed of the particle is proportional to time. Yes, it is correct. The distance of the particle from the origin increases linearly with the time. The distance of the particle from origin is not increasing linearly with the time. It is quadratic function, right? So C is wrong. The force is conservative. What do we mean by force is conservative? The definition of conservative force is that potential energy should be dependent on the position. It should not be dependent on the path, okay. So in this case, acceleration is constant, force is constant, so constant force is always conservative. But we can also derive, so work done is change in potential energy if we are Okay, no. So force is constant. So force is constant. How can we say that force is conservative or not? If force is okay, if force is conservative, when the work done along the closed path will be zero, right? So if force is constant in some particular direction, if we select any, if we select any closed path, suppose this one, we are going from A to B and coming back from B to A, okay? So while going from A to B, if force is in this direction, so work done will be force into displacement. While coming from B to A, work done will be negative because force is in the negative direction, right? So total work done will be zero. Positive along A to B and negative along, exactly same negative along B to A, because throughout the motion force is constant, okay? So constant force is always conservative because work done along the closed path will be zero, right? So A also correct, B also correct, D is also correct. So the right option is A, B and D. See you guys in the next video.